Hi, I'm Bob. Today, let's tackle the problems in the challenge section in Chapter 11, Monopoly and Monopsony, for the textbook Microeconomics, Theory and Applications with Calculus, the 5th edition. Here's exercise A.1. Under what circumstances will a drug company charge more for its drug after its patent expires? As shown in the graph, when the new demand curve D2 for brand name medicine becomes steeper than the original demand curve D1, the new monopoly optimum price P2 will be higher than that before the patent expires, P1. A steeper demand curve means a less elastic demand for brand name medicine. After generic medicine enters the market, some patients switch from brand name medicine to generic medicine. The patients who still stick to brand name medicine are loyal customers and have a less elastic demand. Facing a less price-elastic demand curve that is steeper than the one before, the monopoly must charge a higher price to maximize its profit. Therefore, the condition is that the new customers are less price-elastic than the old customers at the original price. Let's solve exercise 8.2. Does the challenge solution change if the entry of the generic causes a parallel shift to the left of the patent monopoly's linear demand curve? As the graph shows, if the new demand curve is parallel to the old one, the monopoly optimum price will drop. The reason is that at the old monopoly price of P1, the new demand curve has a higher elasticity. Facing a more elastic demand, the monopoly firm must reduce its price to maximize its profit. Why does a new demand curve have a higher elasticity? We recall that for a linear demand curve, the midpoint has a -1 demand elasticity. The points closer to the vertical axis or further away from the midpoint are more and more elastic. That is, the demand elasticity becomes more negative. Now, looking at the graph, the point on the new demand curve that corresponds to the old price P1 is closer to the vertical axis or further away from its midpoint. In other words, the monopoly faces a more elastic demand at the old price, so it will reduce the price to maximize its profit. We can also see it from the equation. As epsilon approaches minus infinity, the price the monopoly charges will fall. We can verify this conclusion using an example. Suppose the original inverse linear demand function is P equals 1 minus Q. The corresponding marginal revenue function is P equals 1 minus 2 times Q. Using the first order condition for profit maximum, we obtain the monopoly optimal quantity of 0.4 and price of 0.6. Assuming the demand curve shifts to the left by 0.2, the new inverse demand function is P equals 0.8 minus Q, and the corresponding marginal revenue is P equals 0.8 minus 2 times Q. Equating marginal revenue and marginal cost functions gives the new monopoly quantity of 0.3 and price of 0.5. The monopoly charges a lower price than before. Let's finish the last question. Some people propose reducing the patent length for drugs, but their critics argue that such a change would result in even higher prices during the patent period, as companies would need to recover drug development costs more quickly. Is this argument valid if drug companies maximize profit? No, the argument is not valid because the monopoly optimal price is determined by the demand curve the monopoly faces and the firm's marginal cost. The shape of the demand curve determines the shape of the monopoly's marginal revenue curve. Given the firm's marginal cost curve, we can find the intersection of the marginal revenue and the marginal cost curves. The profit-maximizing output and price are uniquely determined. Any deviation from the optimal price, whether an increase or decrease, will lower the monopoly's profit. So if the change in the length of the patent does not change the firm's marginal cost and the demand curve it faces, the monopoly optimal price will not change. Thank you so much for solving all the exercises in Chapter 11. See you soon. Take care. Thank you for watching this video and subscribing to my YouTube channel. See you next time.